Awesome.
Okay.
It's working.
Yeah, it looks like it, right? It does look like it is working. So maybe we can go back to actually having this recording so we people that can do that can.
Yeah. No restriction.
Yes.
But we can make it private, but
this one. So let's see if we can close this out. So we don't have to have.
Second camera that allows us to record it?
No, I had it working here, and it needed to work here, so I was using that. That's weird. It's my backup. I did all the prep for this on the Windows side, but I want to prove that this works on any environment, so we're going to experiment with it working here. That guy. All right, confirmation there. Now I just gotta find my presentation. I know it's around here somewhere. Oh, nothing's blown up yet, so this is good. Good start. I have not. Can they? That's a good point. That's a great point. Late was calling, but let's find out what they want. Video. Hey, Layden, can you hear me? Nope. All right, we're gonna get rid of that. No. Let's check the sound. Hear me. So that's in my slides because I can't spell. So everyone that knows me knows that. So hopefully those of you are new. All right, so they can hear me. Yeah. All right. All right. So let's see. Go back. All right. So thanks everybody for coming out. We're gonna be having an introduction to C#. It's been a while since I've given a presentation here, so I'm a little nervous. Sure. Yeah, you guys want to do that? That gives me a little bit more time to be more nervous. Like freeze the kicker. I get it. So I'm Andre Young. I'm the app dev lead for the PAC contract. Also work downstairs for the SSPD project. I'm a developer.
Well, Liam, Code 583 ground systems. Also a developer. I'm working on Store.
I'm Shane Knudsen, Code 583, work with GenSec and primarily developing GSFC.
I'm Ben Vanovich. I'm Code 586. I'm an intern, and I'm working with EOSs.
I'm Karthik, Code 586. I'm also an intern working with EOSGIS, and I'm a computer engineering graduate student.
Marshall Sutton, I'm Code 586, developer on the Discovery project.
Kevin Gray, Code 156, Cold Fusion SQL developer.
Mike Chapman, 545, and developer, and currently working with the PACE project.
Victor Grillo, Code 150. I'm a web developer.
Just on all these forums, see how PAC is helping the customer. So.
Jean Smith, 610.2, the Justice, Sunny State Archives, developer.
Marty McCoy, code 443, JWSC developer.
Enjoyment 2, I'm an intern working for it right now.
Big circle, working 720.
Betty Torres, code 150, financial analyst team.
Jim Amrine, 610.2, Justice Ops.
Manager Lieutenant Battery 662, mostly for electrical.
Dylan Baker, code 583, working on virtual augmented reality pilot project right now.
Oh, cool.
Dylan Caravaggio, code 606.2, for the security.
Jeff D'Agostino, I'm working with 582, currently flight software, currently working on base and ETN.
Shouts high, code 720, project.
Ashley Shane, code 583, code 450,
Alicia, and then
The white mobile code 582, like software development.
Sam Larson, code 699, on the MoMA project.
Joe Williams, 699, using them for Mama Sam, making
All the things.
I'm code 583 GSS.
Roy Ramirez, I'm code 583, I'm also working with GSS.
John 596, work from GPSS.
Scott Brown, 770, NASCOM.
I'm Greg Mosby, code 665, and I do a mix of extragalactic astronomy and infrared instrumentation.
I'm Jack Cohen, code 583. I work on GemSec, GSS, pathways.
Shamia Johnson, intern for code 96, and I'm computer engineering major.
My name is Josh Sylvia, code 610, intern application developer.
Marwan Hamouche, code 40, and SharePoint developer.
Cool. Thanks, everybody. There's a couple new faces. It's nice to see more and more people. So I always forget to mention this, so I put it in my slide. So the pizza that we're eating is sponsored by the PAC contract, so just wanted to give them a shout out. Really appreciate me not having to pay for the pizza anymore. So who am I? I already mentioned my name, Andre. The application development lead, work primarily, again, like I said, SSPD. Downstairs, 19 years of development experience, which is a little misleading because about 8 or 9 of those years were like the same year repeated multiple times. 12 years of guard experience. I love coding and I love learning. Again, like I said, the disclaimer is there. So if anything's misspelled, it's already there. It was late at night when I was writing this last night. And if it was like in the middle of the day, I probably would misspell things anyway, so it doesn't matter. All right. A bit about this group. So we started the group about 4 years ago, I think. I didn't want to fact check anything, but roughly around that. The reason for it is, again, like I mentioned, about 8 of those years were like the same year repeated. When I first got here, it was like, hey, here's your computer, there's your customer. Have fun, right? And it's like there was no growth, right? Because I didn't have a team. I wasn't working with a group of people. The customer was happy with the product, so there's no real need to go any further, right? And that stifles growth. Like isolation stifles growth. So that's one of the reasons why we had put this group together. If you associate with smart people, you can accelerate your technical growth. It's just, if each person does 10 hours of research and then distills that down to 20 minutes across the multiple people that are in the room, just imagine the amount of data that you're getting without the cruft, right? It just works way better that way. A great way to do this is meetups after hours and stuff like that. But I have a wife and multiple kids and a lot of things to do after work. So I try to get to meetups, but I've only been to like maybe 4 in my entire career, right? They're great, but they're just hard to get to. And for some reason, they're always in Virginia, and I don't like Virginia. So it's not close to me. All the ones that I want to go to are always in like the worst parts of Virginia, like Reston, Stuff like that. So,
Start back, keep back Tyson.
no, Weston's awesome, but getting to Weston is like hell.
Yeah.
So no.
Just to clarify.
I mean, however you want to take it.
Marston sent me a meetup for Columbia. There's a lot of stuff. Columbia.
Yeah. So here's my problem. I live in Southern Maryland, which is about an hour from here, and like an eternity from Columbia.
You just live in the boonies.
I do, and that's the problem. So that's why, again, we start the meetup here. Like, how do we do this? How do we solve this? Create a meetup at work, at lunch. And you get all those benefits with none of the drawbacks for the most part. Again, the purpose of this is to get to know each other a little bit better so you can have those things. So, no, most of us are introverted. What he said. Try to get to know each other better, right? That's the main point. A great way to do this is the Slack channel. Here's the Slack channel. We're broadcasting there for the people that couldn't actually physically be here, but they still want to participate. There's a lot of topics that happen in there, a lot of discussion that happens, questions being answered, people getting to know people. It's a good place to be. There's 113 people. When I did this, I think there was like 5 people that were added this morning. So that's probably, again, off. There's another channel, there's an agency code channel. So this is like across multiple agencies, multiple centers in Goddard at NASA. So there's 194 developers in that agency-wide channel. Also a great place to get information and find out things. So can you present? You do not have to be an expert on the topic to present. You'll notice certain things are in yellow because I really want those things to stand out. You do not have to be an expert in any way, shape, or form. I am not an expert in C#. I use it, but I am not an expert. Presenting is a great forcing factor as well for forcing you to learn something, right? So if you're going to present, you're like, I don't want to get up there and sound silly, so I'll learn a little bit more about it. Most of the times, if not all the time, if you're presenting on it, you probably know more about it than anyone else in the room. So don't feel overly nervous about that. No one's going to be like heckling you like, that's horribly wrong. If they do, then we'll probably laugh for a little bit, then we'll kick them out. Come on in, there's extra seats all around. So you don't have to present for the entire session as well. A couple of times we had people present like 10 minutes, 5 minutes. If that's what you're comfortable with, then that's cool. We just need to work it into the schedule so that we'll get everything done. Your topic again, anything tech related. I think one of the first ones we had that was not tech related was someone brought in their Raspberry Pi, and I was kind of hesitant, like, I don't know about that. And it was like one of the best sessions ever, right? And I think a few of you guys remember, what is his name? Ben Guevara. Oh, he's not a developer either. He's just an awesome animated guy, but pretty cool. So we have a list of topics in the developer backlog. Let's see. So there are 48 in the backlog. There's one that's in the planning stage. There's 6 that are assigned. It's not scheduled. This one is for today, and we're going to move it because as of now, it should be done. I'm going to move it later when it works. But yeah, and you can see there's 17 topics that are all listed there. I'll try to go back in and put the notes. We sent out notes for each of them afterwards as well. So that, let's go back to my presentation.
Is the channel still invite only?
Yes, I had started, where is this thing? Wow. So I started a question of whether or not we should make that public. I think it should be public, but I don't just want to say, hey, I'm dominating the group and we're going to make it public. We never really got a consensus on it. I think it should be public. That way, anyone that finds it can come in. There are, I think, hundreds, if not thousands, of developers here. They just don't know about it, the group, right, for some reason or whatever. So we can take that offline and say, hey, we should make that public. right, so getting to the real topic, we have a lot to go through. I'm going to go somewhat fast, but I guess to start off to gauge the room, how many people have heard of C# before? A lot of the room. How many people have actually used it and are slightly familiar with it? Okay, all right. So I'm trying to figure out where I should go and where I should spend my time, right? So that no one's bored and no one gets lost. All right, so it's C with the pound sign. It's pronounced C#, right? General purpose programming language. It's Microsoft's unofficial flagship language. They say, oh, we love all the languages equally, but that's like you're saying you love all your kids equally. That's not quite really the truth. It's nice to say that out loud. Right? So it's founded by Anders Hellsberg, I think that's how you pronounce his last name, and his team back in 2000. He has a lot of different languages that he's been a part of. Can't remember what the older one was, but most recently TypeScript is his newest baby, which we've had a talk on that as well. It runs on the .NET framework, which is kind of misleading. It runs on the CLR and it compiles down to IL. And we'll talk a little bit more about that. The current version is C#7, was released in 2017, a few months ago. It's also one of the most popular programming languages as well, so it's kind of nice to have it under your belt. So a little bit about its characteristics. It's that C, C++, Java style syntax, so that nice curly brace thing that I started in C and then went to C++. I visited Java for a very short period of time and left. So it was, when I went back to C#, it was a nice, familiar syntax, really easy to read, easy to write. Strongly typed, type-safe language. So if you have something in there, for the most part, it has to have a type. Even the underlying type to everything is object. So if you don't give it a type, it is of type object. So everything is type. It's an object-oriented language, memory managed as well. So you have garbage collection. So if that is a problem, you may want to think differently about it. But most part, I've never really seen it be a problem. If you have a garbage collection problem, they say you have an allocation problem, right? And you don't have a garbage collection problem, you're just allocating too much stuff. So you might need to look at that. Event-driven, multi-paradigm. It has functional influences, which is pretty nice. A lot of the newer features in it are borrowed from other functional languages. And we'll talk a little bit about those as well. As I'm going through, if people have questions, just speak up. And we'll try to answer them. If it's going to take a little while, then maybe we'll take it offline. But by all means, if you have questions, ask them. So, history of C#. I don't have dates for these because I was too lazy to look them up. But so C# 2.0 introduced a number of things. Generics, the ones that are in yellow, we're going to actually try to see examples of as we go through. I couldn't put in examples of everything because I didn't want to, and we don't have time. So generics is one, partial types, anonymous methods, iterable, especially when you look at it from a C, C++ perspective. Static classes, implicit typed local variables, automatic properties, extension methods, lambda expressions. I think I missed one in there, but in C#5, we got async and await, which everyone is pretty much trying to copy after that, which is pretty cool. C#6, that one should be highlighted as well. Roslyn. So between C#5 and C#6, they rewrote the compiler in this to C#. I think originally it was in C++. So they rewrote the compiler in C# and they changed it drastically. So now it's not, now you just say, here's my code, compile it into whatever you're doing. Now the compiler runs as a service, so it's always watching and recompiling your code, which really helps for things like IntelliSense, right? Where it's like, hey, I put an object dot something, and it knows what that object is, but it doesn't have to recompile your entire code base. What it actually does is it looks at the line that you're on, it compiles that line, and it sees all the dependencies for that line, and just compiles that one small string. So you get this really fast, accurate compilation as you're typing. Really, really nice. Once you have it, it's hard to kind of go back. Couple more things. C#6, they introduced async and await in the catch and finally blocks. The succinct null checking, I don't know why I didn't have that in there, and I don't have it in my code, but we will do a code example of that because that is pretty awesome. So if you ever had a situation where you're like, hey, I'm passing in an object, but then first before I use that object, I have to check to see if that object is null. Right? And if that object is, let's say you have an object with a hierarchy of 4 things, then you have to check each time, is this sub thing null? Is that other thing underneath of it null? And is that other thing underneath of it null? You get this ugly looking code, but you have to do it, otherwise you'll get no errors, right? They have a really nice shortcut for that, and we'll look at that. C#7 introduced pattern matching in tuples, or it doesn't introduce tuples, but it makes it a lot easier to use in the syntax. So it introduces some syntactic sugar for tuples. Let me get my phone so I can see what's, oh, there we got time up there. All right. All right. So where can you run C#? Well, I should ask that question before I go there. So if I'd ask you, where can you run C#, where would you think? Everyone's going to say Windows. So Windows is off the table. Where else can you run C#? Huh? Yes, anywhere you have the .NET platform, but that's a trick answer. So where can that run? Where can that one run?
Well, there's a mono.
Yeah, there is Mono, which allows you to run it on Linux, right? So you can run it in Linux. Where else?
Then I was telling I assume through mono.
Yeah, one of the reasons why I'm using this is to prove that you can run it on OS X, right? No virtual machines, no hidden figures. Yeah. All right, so Windows, desktop, server versions, you can run it there. Anything Windows related. Mac OS X, you can run it there. Linux, you can run it in containers. You can run it on mobile, so all your phones, you can run it on your phones, right? iOS, iPhone, iPad, all that, Android. A lot of games are written in C#. So C# is like one of the, besides C++, one of the top gaming languages as well. Like guy over here mentioned virtual reality, augmented reality. A lot of that's written in C# as well. Scripting, so you don't have to compile it. Cool scripting way you can use, and that's linked there. I'll send these notes out too as well later on. You can run your builds in C#. For builds for like you're going to build Go or whatever you want to build, you can orchestrate that in C#. Internet of Things, so IoT devices, you can run it on that. So if you have a Raspberry Pi, you have a Arduino, that sort of thing, you can run in there as well. So pretty much C# is what Java was supposed to be many moons ago, where it can pretty much go everywhere. So I mentioned Roslyn. That's the compiler as a service. And enables a bunch of features, but again, this is one of the last slides that just got moved up to the front when I was writing it because it makes more sense here. One of the biggest things though is it brings IDEs, it brings language support to any IDE or editor that you're using. A lot of times when you say C#, oh, you're thinking Visual Studio. But you can run it in Sublime, you can run it in Vim, you can run it anywhere you want to, because that language service sits out there as a service, giving feedback to your editor to give you that IntelliSense within your editor just by a plugin. Code, which does not have, it's not Visual Studio proper. It's just like Sublime. That's not like, it's like Atom, but better, in my opinion. Okay. And it also enables really good refactorings because it knows your code. It's not just looking at your code on a deeper level, right? So some of the refactorings it could do for you are really, really powerful. It can even suggest refactorings for you. It's like, hey, that's not that smart. Here's a better way of doing it. Yeah, really cool. So
there's a problem with the broadcast. Showing the wrong screen.
Okay, thank you. Let's see if we can fix that. Someone's trying to mention that to me. You're online, right? So let me know when it's okay. So let's see if we can get. Let's see if we can get this to work. Might have been when I jumped out of the presentation. Can you ask them if they see it now? I'll take some pizza. Intermission. Are they good? Haven't responded.
Surprised there's no indicator here to say your screen is being shared.
Yeah.
There's no visual prompt.
I think what happens when I jumped out to go to the website. Okay. Everything got confused. So let's fix it.
So it's fine on the Hangout, it's not fine in Google Live or YouTube Live.
Okay. Can
Can you try muting everyone?
already in there. I'm sorry, technical difficulties. Technology is hard. Two of these open. This one I don't need, so I'm not joined. Let's try this. Now.
Confusing that when I start learning
I just
English.
get confused.
Now and now.
Yeah, I don't English well.
I had to learn when I came to the US. So
Gosh. All right.
sounds the same.
Yeah. I hate to do this, but they might be short. Ah. All right, should be working now. If not, we're gonna have to go on. All right, cool. All right. How many developers did it take to get a broadcast going?
All of them.
Plus one. Off by one error. All right. Let's try this again. Okay, so just a quick look at the syntax of the language, right? So you have your nice curly braces, you have your namespaces, your using statements. So your using statements are pulling in packages or, yeah, bundles of code, right, more or less. Your namespace is what you declare. That's how you name or package those packages. We have classes. Again, it's object-oriented language. We have functions, and this function here is what you would get out of the box for a console app, or your entry point into that app, right? Interestingly enough, ASP.NET Core, which runs on, is now like the console app versus like this magical thing that just runs. That's to make things more easier. So a couple of things in here. So we have what's that? It's an object. A right line is a function on that object, and then it's the parameter is hello world. So if we were to take that and run it, which let's see if we can. That's no. I wonder. Let's not screw things up. Let's not screw things up. At the end, I'll go through and I'll do some code samples but just so we don't mess them up online. Right? So some C# basics. Declaring an int. This is the syntax for that. Declaring a string, a boolean, char, a letter, right? This looks very familiar if you've done C++ or Java in particular. Decimal is the same thing like here. And notice a little M at the end, so it knows that it's a decimal. Double, float, date time, time span, there's another type. All these are built-in types. There's a bunch of other ones that just didn't have all the time. One of the things that I really like too as well is you have type inference, right? So I'm declaring number, but I'm not telling you what type it is, but I'm passing in a value of num, and it knows num is an int, so therefore number must be an int, right? Same thing here, I'm declaring a variable annuetta. I'm passing in the value annuetta. Annuetta is a string, so therefore this one is a string.
What's the difference between string and char?
So string is a list of char, right? With some other, string is a class, and that's a good point. So string is also immutable in here. So if I say var lowercase annuetta equals uppercase annuetta, then I say later on annuetta equals Andre, I now have two strings, right? Because you're not mutating the first one. Every time you ask for one, you're gonna allocate a different one. So imagine you had this in a type loop. You're gonna be wasting a lot of memory if you're doing that a lot. So in that case, you would want to use a different type, a class called a string builder, which is going to be a buffer, and it's just going to keep changing that buffer. And at the end of that type loop, you can say string builder dot string, and it'll give you the string. Right. So that's a good question, and it's a little bit of a gotcha there on how, again, if you have let's say you had that in that type loop and it was going over and over and you kept getting garbage collection, it's not because the garbage collector is just trying to ruin your day, it's because you have an allocation problem. You're allocating a bunch of memory and not really cleaning it up, right, inefficiently.
So are the colons mandatory?
Yes, the colons are mandatory because colons should be mandatory everywhere. So no, they are though. Yeah, yeah. I spent a lot of time in a language that did not have the colons, and so when I came back to C#, the colons were so irritating. Now that I'm there, when I go back to other languages that don't have them, I try to insert the colon. So it's kind of whatever you used to.
You would think that for a language that was first developed in 2000,
yeah,
they could do away with colons.
So I didn't put it in there, but honestly, I think what C# was built for was the Java without being Java. It's like, we're going to do Java, we're going to do Java right, so to speak, but we're going to keep it close enough to Java that the Java people can come over to C#. Right? They started with the J++, I think, and then they got like sued, and they're like, well, okay, we'll rename it C#, and we'll do it that way. But interestingly enough, a lot of the things that were problems in Java that they couldn't necessarily get rid of, because this started later, they avoided those things, like multiple inheritance, that sort of thing. You don't have multiple inheritance in C#, which is I know you can do that. Wait a minute, I think maybe C++.
More than one thing.
Yeah.
At least historically, you can only inherit.
So I'm thinking C++ then.
Sorry?
I'm thinking C++.
Yes.
Yeah. All right. So branching. A couple of things on branching. So you have your if statements. In here, this is a Boolean. I believe I declared that last time. Yeah. So this is a Boolean there. Name is a string. So I'm saying if this thing is true and this thing is true, if either one of these is false, it's going to just short circuit. It won't go any further, right? And then this is the OR statement here. So if I say name dot contains the letter A, then go into here and console write some stuff. Else, go down here and say I don't know you, right? Same thing over here for a switch statement. Switch or select. I'm not sure how else it's named in other languages. So you have your case statements. Huh? Someone had.
So these could be strings on the switch.
So these, historically, these had to be a constant, right? So it had to be a string, an int, enum, right? Something like that. That's actually been changed now. So I'm going to show you something on that later on when we talk about pattern matching. So if the name here equals Andre, then this gets run. And notice a break in between all these. If you don't put a break here, it'll fall through, right? And it'll do everything below it. Yeah. Oh, wait. So this is an interesting one. Go to. Go to is there. It's a real thing. You probably should not use it, but it's your foot if you want to shoot it. But it is there. And if you have a valid use case for it,
You don't.
I've never used it, but I figured like for demo purposes. Yeah. So interesting enough, that whole thing why go to is not used anymore, if you look up the paper for why that's so, it's not really valid. Right? So you think about it. All your functions and everything else are go-to statements, right? That's what they are under the covers. Right? It's like do this, then go here, then go back. That's the other thing.
So it's go to may be harmful, not go to is harmful.
Yeah, yeah. It's all in how you use it, right? All right. So looping. Interesting enough, when I ran this, after I copied and pasted into the thing, there's an infinite loop in here. So hopefully you can find it. So
can you find it?
Yeah, can you find it? There's a test. There's a test at the end. So you have your traditional while loops. You have your do while loops, where basically will say, do this thing, and then check to see if with a condition. And there, you found it. There it is. And you have your for loops. So you can say for I equals whatever. Second one is the condition. Third one is what's going to happen every time you go through the loop. And it doesn't have to necessarily be an iteration of a letter or an integer. It could be whatever you want it to be. You loop through there. For each is pretty nice because it takes the object in it basically gives you one of each of the objects in the list all the way through, right? So there's no, you notice there's no index here. I'm just saying person, and person is a string from here, and I get that string out. So I get it puts it into that variable, and I have it there. One other thing to mention here is that the way this is written, I condensed it and made it so that it fits on the screen. But there's ways that you idiomatically write C#. Like the curly braces are not usually on that line, right? They are usually on the line after. For all these things, you can actually, for all these things, you usually want to wrap them in curly braces, just for the fact that if you go back in later on and add something to that thing, you're not getting a bunch of other garbage in your diff, right? You're just getting the diff. You don't have to, it's just idiomatically, that's what you would do. Yeah, good practice. All right, so classes. We're gonna look at this one as an example. Hey, come on in. So if I want to create a pet shop class, then I just do public or whatever I want. It doesn't have to be public. I think most of the examples in here say public because it's just easily typed. But you can do protected and private and a couple other things. I'm declaring a property here, so automatic property. So for those that do Java, I believe, and C#, you have getters and setters, right? So this gives you an automatic getter and setter. You got a question? Oh, okay. So it gives you an automatic getter and setter. So behind the covers, what this does is create a private member variable, and it gives me a public getter function and a public setter function. That sets that private variable. The second one here is interesting. This is how we haven't seen this. This is another public property. I'm declaring a list of animals, right? And so this introduces the generics, right? So it's not that I just have an array of things. I have a list, which is a certain type of array of animal. Something in that list that's not an animal, it would not work, right? Because it's type safe. It says the only things that go in here are an animal or something derived from an animal. Okay? Very useful to have. So our animal class has a couple of things in it. Again, a name, a cost, a danger level, because some animals are dangerous, and a function called speak. And you notice here it has virtual. What that allows me to do is that if I declare later on a cat, then I can override that speak function and say my cat says my name, meow, or whatever. The name says meow. Another thing in here as well is the string.format. You notice here is this syntax. This is string interpolation. So it'll take this .name, which is the name from, again, this guy, and insert it here.
Okay, so in the previous page, suddenly all your publics are capital on the right-hand side? Is that just C# doesn't care?
No, C# very much does care.
Okay.
But copying and pasting into this guy,
Right.
they tend to mess things. I tried to get the spacing out, and it took all the spacing out, and it was like a horrible mess. So we're gonna go into the editor and actually write some code and do some things. A lot of these were copied from the editor, from the example. So here we have a cat, which is of type animal. Which is derived from an animal, right? And it has this other thing here, which is an interface. We haven't talked about that yet. So you can declare interfaces. So although you can't inherit from multiple object types, you can inherit multiple interfaces. So if I wanted to say, like, I have a list of things that speak, then they can be anything. They can be a person, they can be an animal, they can be a cat, they can be a dog. As long as they have a function that is called speak and returns a string, then I can iterate through that thing and call speak on each one of them. So that's really useful, especially when you start doing over instead of inheritance, which inheritance can kind of shoot you in the foot sometimes too as well. So we also can inherit from things that are inherited. So we have a tiger, which is a big cat, right? But the danger level on the tiger is like way higher, right? And we have a dog, because not everyone's a cat person. Right. So I mentioned this before. So we have another switch statement, but now instead of switching on a constant value, we're switching on an object type. And then the case statements in there say, hey, if you are a tiger and your cost is less than 400, then console write out, hey, you're a tiger, but hey, you're on sale. So that's maybe okay. If you're a cat, then print this one out. And if you're a dog, then print this one out, right? And also, you notice here it says, if you're a dog, then basically assign your variable to this D, and then I'm using that D inside this variable here, right? And inside of the string interpolation. You notice this is also string interpolation, not string interpolation, but it's another way of formatting the string. Name here, I just put a 0, and you can do 1, and then 2, and 3, and it'll be the places for the variables that came after it. Interesting enough, if I were to take this case statement here and put it down here, it would flag it. It would say, hey, that's a problem, because you will never get to that, right? Because a tiger is a cat, right? So the pattern matching would match on cat first and never go to tiger.
I'm wondering about the 0. Why is it inside the string?
Which one?
The 0 and the, yeah, because as I thought that it'll read it as a string and output the 0 without the name.
Or
yeah,
here?
it'll input the 0 as a string.
Oh, no. So that
right.
curly brace there.
Yeah, the curly brace with the 0.
Yeah. So what that's saying is that's a placeholder for the first variable that comes after this string. So I can have curly brace 0 with a 0 inside of it, curly brace 1, curly brace 2, and if I had c.name and then c.cost and then c.danger level after that, it'll insert them in that order, right?
So even though the curly brace is inside the string, it'll read it as a
variable, as a placeholder for a variable that you're going to insert later.
That's how right line will interpret it.
Well, that's how, yes, right line automatically does string.format for you. I probably should have mentioned that. So that's a function of string.format, and right line will actually do that for you.
I mean, as a literal, that's just a literal string that's got that further reason.
Yeah.
Exactly.
Very good. Tuples. All right. So sometimes you have a function and you want to return more than one thing from it. So tuples are a great way of doing that. You know, you can historically what you would have done is say you got to return two things, then you create another type for it or struct or whatever, and you get all these things polluting these types that they're not really types in your system. They're just there because you need to send two things back. Tuple is a better way of doing it. You could always, I think you could have done tuples from C#4 or so, but the syntax was like the one below where you say, hey, here's a tuple, and the first thing is a string, the second thing is a decimal, and then when I'm sending it back, I say tuple.create, put the name in here, then the cost in there, and it'll send it back. Useful, right? Yeah.
What's a tuple?
What's a good definition for a
It's a good
tuple?
way to return more than one thing. It's okay.
Oh, okay.
When it comes down to the low level, you return a list of objects from a function.
Oh,
yeah.
okay.
Add a little
Yeah.
syntax to the step trigger, so
Yeah.
it doesn't look
And
like you are.
it's immutable, you can't like, usually you can't add stuff to it or change things.
Mm-hmm. Yeah, very good. Thank you. So the new syntax is the one above. I should have probably put it in the order that it came in. The syntax above says that, hey, I'm giving you a string and I'm also giving you a name for that string. So that I don't have to, before the second one down there at the bottom, if I wanted to get name out, I had to be like tuple space 1, tuple.1 or something like that for that first position, right? It's position dependent. Now it's not really position dependent. If I set that to a variable, I can say variable.name, and it'll give it to me regardless of which order it's in the tuple. It's a little syntactic sugar. This is actually doing the thing on the bottom. Underneath the covers. Yep.
I got a quick question. Like, you have more than two, I guess.
Yes, you can have as many as you want. Up until the limit. I don't know what the limit is. I can't remember what it was. It's like 17 or 18, something ridiculous. Like if you're doing that much, you got to like reevaluate your life. Something's wrong. Link is another one. It was not highlighted in the yellow before because I didn't want to go back. Link is really, really, really cool. It borrows a lot from functional programming concepts. It enables you to chain multiple things together. I'll show you examples of this in the next slide. It can be used on anything that implements an IEnumerable interface. And I think some other things that don't, but they're like more edge case. It makes your code easier to read because you're not, let's say you want to grab the name. You had a list of pets and you want to grab the name from each of the pets. You do a for loop over that list of names, and you'll create an array and then put one by one, put the pets in there. Think of how you would do that in SQL. You would just say select pet name from this list of things. That is how you would write it in Link. So your code is like intention revealing. So if they go back and optimize the implementation for that, you get that optimization for free. Right?
And it's implemented as a package. You just declare it as a package at the beginning.
Yeah, you just pull in the namespace and it'll come in for you. Very similar to SQL. So here's some examples of it. So this is again assuming the class structure that we showed before, where you have an object called pet shop. That object has inside of it a list of animals, and each of the animals has a name, a cost, and a danger level. Right? The animal names I can do shop.animals.select. And that's read. That part after that is read. X goes to x.name. So basically, say for everything, every item in that, every animal in that animals list, put that into the variable X, and then take the name off of that variable, and then put those into a list and then send it back. Right. So that's what this whole thing does. Right. That one line does all those things. So that for loop that I mentioned before, this replaces that for loop. Right. You can do other functions on there. There's a lot of other ones I took out just a couple of them. So you can have an aggregate function, which is like a fold or a reduce, depending on which language you're in, right? So basically what this says, it says, give me the total cost of all the animals that we have in our inventory. So you can say shop.animals.select the cost. So first it's going to give me a list of the costs, right? And then from that list of costs, I want to aggregate each of those costs and run this snippet of code on it. So it's going to say whatever the value was before plus the next value. X being, I should have did it that way, but I didn't have enough space to run it all the way through. So the previous value was X, the next value is Y. Or current value is X, next value is Y. And so you're running through, iterating, adding those things up, right? You can do other things. You can do like a where statement. Go ahead.
Sorry, I actually didn't get that. Okay, I'm used to kind of like reactive style. So
Yeah.
I'm saying like select X dot cost, maybe to aggregate. I'm expecting cost to be some sort of number at that point, right?
It's because you had cost is the one number, but you selected it from each of the. So think of select as map, right? So select is the same as map. So it's like map over all these things and give me back a value. Run this function on each of these values in that list.
And aggregate is like reduce.
And aggregate is like reduce. It's saying now run this function on each of those values, but only give me one value back.
So I'm a little confused in the Y part. Yeah.
Yeah.
It's two input. Okay.
It's
so
two. Yeah. This is just two variables that go in. The starting variable is this, so that's the 0.
And your other, I see. Your
Yeah.
Y is another input variable too.
Yeah.
For that.
Yeah.
Okay.
Yeah.
Is this what JavaScript stole arrow functions from?
Yeah. Yes. In a way, a few things came.
It's been around.
No, but I think that was.
Arrow functions specifically in JavaScript.
I think what's name started that one. CoffeeScript. And where they got that from. Yeah. Yeah. I think so. I don't know. So either way, there's a where you can do a where statement here. So it's saying, hey, give me all the animals where the danger level is greater than 7. So it'll go through and grab all those things. You can do order by. So you can say, hey, give me order the animals by the danger level, and that's going to go from the lowest to the highest, right? And then give me the first one or the default. If there is no first one, then give me back null. That's what that's saying, right? Interesting enough, you can, inside of this area here, I could have put this in there. Or not that, but I can put other statements, other Lambda expressions inside of there. That one probably wouldn't make sense, but this you can put other Lambda expressions inside of here. So this one here is saying, give me the second most expensive. So basically take off the most expensive one and give me the next 2 that are in the list. So it's saying, hey, order them by their costs, right? And then skip the first one and then take 2, right? Very nice, right?
It's C#, 0 index.
Yes, 0 index. But this one is going to say skip 1, not like skip 0 then 1. So it's not going to skip 2. It's just going to skip 1,
So
and that's
that
going to take the next.
take the second position?
Yes, it'll take the second 2. Let's take this. This
So
one will
why did
take.
you do the skip? Why not just do take?
Huh? So let's say there were 10 in there. I only wanted the next 2. I wanted to skip the first most expensive one and give me position. If you're doing
I'm
0,
just
it's 0
looking at,
next.
sorry, I'm just looking at your variables, the second most.
Yeah, because I started off writing it differently,
Okay.
and I didn't go back and fix the variable.
Right, I got it.
At first, I was only going to get the second one, but I'm like, well, that's very similar to the example above. So I want to show the
Second and third.
Second and third, yeah. So this one says comments. So remember how I said select is like map. So for each of the lists and the animals, go through and call the speak function, and that'll get back an array in the comments of everything that came out of speak, all the outputs of speak. You can do, you can create another object type altogether. So like I say, for each of the objects in an animal, give me back an object that has a name and a cost only. Or it can be anything you want in there as well.
How do you do less than or equal to in C#? Like there's the assignment operator equals.
So this one, just flip this arrow over. It'll be less than or equal.
Oh, okay.
Yeah.
But it's not confused with that. It's like some sort of assignment operator. Where
Oh, this one here?
Yeah.
Yeah. So if you notice this one, you see where the equal is?
front.
Yeah, and then this one's here. So this one looks like an arrow, right?
Yeah.
So it's always like this thing goes to that thing over there, it's that arrow. I think how they call it in JavaScript, but and then this one is slightly different. So that's the thing with older languages too. Like when something new comes up and they want to bring it in, you can't break the stuff that was there before, right? So you always have to figure out a way that you can bring in this new thing without breaking the things that were there prior. All right. Someone I think mentioned testing when I asked for, hey, what do you guys want to talk about? This is not directly in C# itself, right? But these are different libraries that you can use in .NET to test it. You can use C# to test C#. You can use VB to test C#, and you can use F# if you want to test C#. I didn't mention that before, but all those languages are interoperable, right? So I can call F# code from my C#, and I can call C# code from my F#. I can call VB code from C#, vice versa. I can't write them all in the same class, right, or in the same project, but I can refer to them easily. You can also refer to and call C++ code. You just have to mark it unsafe, right? It's like, this is no longer memory managed area. Go do a thing, it's your foot. All right. So this is an example of how you would test something, right? So you have our fact, which is basically, what do you call those things? Crap, I can't remember what they call it right now. Yeah, it's like a decorator. I can't remember exactly what they call it, but it is your decorator. So these are two decorators. One is this fact one is saying that this is a test class, a test function that comes next. This is just a trait to say, hey, when I'm looking at all my tests and I want to filter them down by things that are related to the persistent security lock cache, then I can just put that in there and it'll group them together. The arrange, act, assert pattern is one that's very common. So you arrange your object, you do the thing that you want to do a test on, and then these functions here come from the XUnit text package. So it's basically saying assert that the result that came from this function is not null, and assert that there are 4 items in the list that came back. So that's testing there.
You think it's backwards in the case of decorators?
You can. So you can do a number of things in there. You can do aspect-oriented programming using decorators. You can do a number of things. You can do, I believe you can do assertions inside the decorator. So you can say, hey, this thing's always going to, before you even call this function, if you don't meet these criteria, then don't call it, that sort of thing. So what is C# good for? Large programs, team collaboration is huge. Like if you're going to do a rename on something, and it's going to ripple through your entire code base, or you're going to change something, then that type safety really helps, because it will go through and it'll fix things for you, or it'll just say, hey, here's all the places where it's broken. Go fix it. So easy refactoring. There's a number of other things. I just, again, ran out of time. What is not good for it? Because everyone's always like, oh, this language is so awesome. It's so awesome. Dynamic processing, dynamic, like unstructured data, like I say, you're getting a lot of data in and it's not really structured. They have a type called dynamic and another type called something else I can't remember that is used to handle these things. But it's like you're in C# without any of the benefits of C#. It's not, in my opinion, it's awkward to use. So if you're doing, if you're processing dynamic unstructured data, like, then I wouldn't use C#. Yes, it does. Yeah. You also have pointers and a number of other things that you generally won't see in a C# code base, but they're there if you need to break out and say, okay, I need to do some really low level type stuff. It's there for you to use. Interesting enough, you can also, C# is compiled and runs like as an interpreted language, an IL, but you can compile it right down to machine code as well if you want. So you're not running, you don't have the overhead of an interpreter or anything like that on top of it as well.
I'm curious about that too. Java having the JVM. And CLR is like basically bytecode for the .NET world.
Yeah.
Okay, so
or IL is like the bytecode.
So what?
The IL.
IL.
Yeah, which runs on the CLR, which is like running on the JVM.
The CLR is okay.
Yeah. So again, remember it was like a copy of Java.
But it sounds like it gives you more access to underlying.
Yeah, so you can break out and get down to those lower levels if you want to. You don't generally see it done. I've never seen it done, but if you look at maybe some really highly optimized projects, they may do it. But for the most part, I'm writing that sort of thing. You don't need to do it.
Game engine, whatever.
Yeah, Unity. Yeah.
Okay, so what's not good for it is basically big data. Good, or I would ask, is it good for GUIs, the front ends?
Yeah.
Can it handle scientific programming quickly?
It's the only thing I found is not good for is that unstructured data. Like if you're getting a lot of unstructured data, like I was working with an API that was written in Ruby, and they just did not care about how they put things together. It was like this thing came in this way and this other thing came in this other way, and it was just like, just throw the data at you. And I'm like, and for all those things, I had to now create a class or a type for it, so that when I pulled it in, it would go in the right place. I can access it. That was just like, and I wouldn't do this again. Like going back, I would just write that in JavaScript. It's like, well, you're untyped, so I'm untyped, and we're gonna play nice together. You know, we're gonna have fun.
So it has like similar issues like Java does with, say, JSON or XML unmarshalling, where you're trying to take even structured data.
Yeah.
If it's so nested, you have to write a class for each of those.
If your put is known, then you don't have a problem, because it'll do that for you. The problem I was having is they were throwing in different data structures from the same API. Wow. All the time. It was like, you guys really just, yeah. So it was not good for that. So if you have known structured data, you're fine. You can even take the JSON and say, here's my JSON, create these classes for me, and it'll do it. It's fine.
Oh.
Yeah.
So it'll actually like create classes.
Yeah. Yeah. So that part.
It kind of does that.
Yeah, it works pretty well. And you can tell it, hey, I care about these fields. If these other fields are there, then ignore them. Whatever. It's just when you're getting a lot of data and you don't know what that structure of the data is going to be. Then I would go with more of a dynamic, untyped language. Yeah. So, future C#, it is moving somewhat fast. It's one of those big primary languages that they can't really just like, oh, we're going to throw all this new stuff in there, because every time you add something new, right? But it is moving pretty, the agent size of it. It's open source. So you can actually read the source code for it. You can see the discussions. It's on GitHub. The proposals are there. The design meeting notes are also there as well. So you can kind of glance at those things. I mentioned before, I know it's after 1, but if you guys want to, we can look at some of the actual code. So if you were running on let's say you're running on your Mac or whatever, and you wanted to create a project, which you guys probably can't see. So let's do all right, so if I want to create a new project, I can do .NET new. Do that. Okay, sample 2. So this is going to create a new console app and call it dev sample 2. And that's done. So we're going to CD into that guy.
What's the dash O?
Can't remember. No, I think it has something to do with the naming, the name that comes after it for the folder. But I can't remember exactly. So we're going to open that project in code. So we open that up. This is what we would see. This is what it gives us out of the box. It gives us just that program thing. Here's the C# project file. This used to be in, what do you call that thing? JSON. And then they switched it back to XML because they like being evil for some reason. So we go to our terminal. We want to restore the packages. We just do .NET restore. That should restore our packages, which this thing already did for us, but just so you know what the command is. If we want to run it, .NET run. Actually, let's do this first. Yeah. So what I'm typing in here is just a terminal, but it's just built into the editor. So it's easier for me to show you those things together. So this is basically going to run this program, and it says hello world. Just print out hello world there, right? So let's do some more interesting things. Let's show that pet shop thing that we had before.
question. Is there like a repository for like all sort of servers or buggers?
Yes, that's great. So I don't know why I didn't mention that. You have NuGet, all the .NET packages. So again, you didn't have to be C#. It can be anything written in .NET. If we would go to have all of our packages. So right now there are 3,243,525,000. A lot of packages.
81,000.
Ah, yeah. Okay, I was like, oh, that's crazy. Ludicrous. Ludicrous.
Microsoft finally took over.
Yeah. Thank you for that. I was like, that, man, that's a lot of packages. But I tend to use the same ones over and over. You mentioned before JSON handling. It's like the primary one for that. That's this one here. Any it is the test framework. Any framework, the links in test that I showed you guys before. Any framework takes that links in test and builds SQL statements for your database. So you can, in your code, you have if you're what it can do is keep your code, your objects in your database in sync. To refactor, you want to change your person name to first name and last name. Class, you would run an any framework, change it in your database, right? Or vice versa. I think mostly now is code to database. It used to be database to code, code to database, or model to both. But the newer versions is mostly code to database sort of thing. There are a few legacy front-end packages in here, but for the most part, they've stopped doing that, and they now just use the JavaScript package, NPM, for those front-end packages, because that makes more sense instead of trying to redo all the things. Right. So
How's threading?
Threading is good. I don't use it that often, but you can absolutely do it. Yeah, so you can do threading. Asynchronous programming is really easy in there as well. Let me see if I can pull that one up, because I have and this is the sample code base. I'll put this in as well. These are a lot of where the samples came from, the notes. They're all in here. A real code base in C# looks like this. So let me see if I can find somewhere that does some threading. This. Sure, we can go in there. All right, so let me do this, because this is the part. There, I'll describe it as I'm looking for it, but let's say you had that for each loop that with threads, or one of the ways you can do that with threads, you can just say parallel.forEach. That's it, and it will parallelize everything in that for loop for you. Those things back together, and it'll marshal all the data that you need to go back, and it'll handle all the threading for you. You can go down and now, if you want to go down and say create this thread, and then run this thread and do it manually, you can do that as well. But there's a lot of layers that you can use before you go down to that layer, if you choose to. Again, with threading, you have to be careful to make sure that the cost of creating the thread is not more than the value you're getting out of the parallelization of the thread, right? So if you're going to do that sort of thing, but that's.
Is there like a magic working in the background? So parallel laddering?
Say it again.
Is it like a little thread pool?
Yes. Yeah. It only creates as many threads as it needs to do the job.
Okay.
Right. So it will say if the thread from iteration 1 is now done, and then you need another one, it will just reuse that one. So it won't create more than you need. Let's see. All right. So, it's not really a good example. So the async model as well. So if you look here at this function, can you guys see that? It's horrible. I should probably not do dark theme, but I really like it. Not that one. I'm trying to find a good one. So this one here, where it says delete async, this is an async function. So basically what's going to happen when it gets to this point here, and it says await, that's actually going off and doing something, some asynchronous work. It's going to return that thread back to the pool until that work, until it gets a response back from that asynchronous task, and then it'll actually, as it's doing, it'll unwind your stack and put it in like a memory buffer somewhere and return that thread back. And then when it gets response back, it just puts all that back in memory again from that point in the program. So that's really good if you want high throughput. You can just say, make most of your code async, and it'll just keep, it's like by default what Node does, right? So that's also pretty useful. If you use async here, you have to make your, if you use await, you have to make your function, put the keyword async in there, because now it's going to unwind this all the way up the stack to the point where the thread was introduced, right? So that it can give that thread back to the pool, so it can handle another incoming request. Right? So if you had, let's say you had a long-running SQL statement, and it's being called a lot, then you would make that function async. And it's like, hey, start this thing. And in the database, because it doesn't work, say, grab another one and start that one. Grab another one, start that one. Oh, you're done. Okay, let me process you. Right? That sort of thing.
Is there a way to notify that you're doing this?
It won't go on any further. So it'll put the value here. What I could do is say, if I wanted to say this, I can say this, all right? That's still async, but I say, I don't care if you do this function down here until, but I want you to wait to return. So I can say await entity here, all right? So this is now not the object itself. Let's say this is better yet. This is gonna throw some errors, but that's now a task, right? And then I can say our entity equals await task. So what's going to happen is it's going to send the function here, which is a database call down the line, right? And then it's going to say, give you back a task. It's like, hey, did the call happen? Great, that's all I care about. Keep going in your code base. And then when you get here, before you return, I need that value out of that database call. So wait here, but don't just hold a thread. Give the thread back to the pool. And when you get the value in, restart the thread in there and give me the value back. Right? That one's really useful. That's actually going to come to JavaScript. The next version of JavaScript, async await, is going to be in there as well. And a couple other languages are picking that up as well. No, it's doing what promises do, but you know, you have that syntax before with the callbacks, and promises kind of help a little bit, but it's still kind of going all the way in. This makes everything linear, right? It's like you're still doing asynchronous programming, but it looks synchronous. Yes. Do you guys want to see examples, or do you guys want to just ask some questions? It's up to you. You can watch me try to code live. I practiced. Huh? Yeah. But yeah, totally up to you guys. I personally, like I said, I like the language a lot. It's C or C++ or Java developer. It's very comfortable. It's actually built to be like the language, but simpler. It's not as complex as Java is. Because it's like, hey, what was the intention of what Java did? But since we're coming later, let's make it simpler. Right? Let's make it easier to use, that sort of thing.
So performance-wise, how does it compare with Java?
It is up there with Java, if not better. So a lot of that depends on your on the environment. So like for the JVM, you can have two Java programs, exact same programs, but they run completely different because it's how you tune your JVM. right? So the same things can be true with certain features in the CLR, right? Comparison-wise, I think it is. I'm thinking about ASP.NET, which runs on the .NET framework, and it's one of the faster. The newest version is one of the fastest versions compared to like it's faster than the corresponding Java version. But that's
the
a higher level.
I think it's faster on Windows, but Mono versus JVM, the JVM tends to beat out Mono.
Yeah, Mono. So yeah, Mono was an like this .NET and C# is an open spec, and Mono was their implementation of that spec. Since then, that was Xamarin, so they're the ones that were doing the iOS and Android and Linux development. Since then, Microsoft has purchased them, so now they're a part of Microsoft, and a lot of the code from both are being shared. The garbage collector in Mono was never as good as the one in the Microsoft one. So now they're taking that code and brought it over to Mono. In my opinion, they haven't said this, but Mono will go away. Core, which runs on all of them. Right? And .NET Core is the one that's actually because it's
making a bunch of good moves to cross-platform.
yes. So there's another thing too. There's these implementations of .NET had similar APIs or close to it. Now what they're doing is saying we're creating a thing called the .NET standard, and they're layering that on top of it. It's like a bunch of interfaces. So you shall implement these adhere to .NET standard 2, then you implement these interfaces. The .NET standard, and then you can use that in any of the places .NET runs. Right. So I'm saying if I target .NET standard 2, then that same code base can run on Mono, Linux, iOS, wherever that handles .NET. And you know that it's going to operate similarly. One of the ways you can get a lot of performance too as well, as I mentioned it before, is that you can compile it down to machine code. No longer have the interpretation layer. And that gives it a big performance boost as well. Any other questions? I don't know if anyone online had any questions, but. All right, well, thanks for coming. I'm gonna put the notes in there. That's the code sample and how to build it is in there. Really quickly, I'll show you guys this one thing. If you go to .NET and you go here, it says C#. Again, like I said, it's the unofficial language because there's multiple languages, but the only one on the page is C#. So.
Good a lot of it.
Yeah, like I said, if you go look up, for example, the one you find is C#. To the tutorial, a lot of the stuff, and you can actually make a step back. You can say what your language experience is. So like I'm coming from a C++ background. Yeah, or C background. I know it adjusted for you, right? And I'm using Visual Studio Code, I'm using Visual Studio, I'm using command line, whatever the case may be.
Does it have a repo?
Yes, that's what I wanted to show you. So if you go here and show the code sample, then you like show me, because I don't trust you, because you guys lie. Do that, right? And you can actually change this, right? So you can say, instead of saying hello world, you say hello. Group, I can't spell. Group. Group. All right. There you go. So you can try C# out without actually downloading or installing or doing anything. And this is a full environment. The only thing I think here, it doesn't give you IntelliSense. Console. So actually it does a little bit, but not fully. There was something I tried earlier and it's like, no. Maybe it was like a local variable. No, it doesn't. No, name. It didn't do. You guys can figure it out as you go through.
But you might also have a free work on, since it's compiling on a cloud.
Yeah, 'cause it can't compile it in the browser, right?
No,
So
but I'm
interesting
saying
enough,
you can
there
do some testing on a cloud.
yeah, limitations on there as well. They'll kick you off of your things like infinite loop or something like that. But yeah, there's a couple projects out there too. So there's interop between C# and JavaScript. Or C# and running it as JavaScript, but those are all like very fringe sort of things. People don't, it's you can do it, but again, it's your foot.
Wait, so you write C# compiles to JavaScript?
Yes, you can write C# in your JavaScript.
Okay.
Yeah, you can write JavaScript in your C#. That's what. No, it is a thing. Someone somewhere took some time and did that. But yeah, so I'll send this with the notes as well. Cool. All right. Thank you, everybody, for coming. Hey, make sure you all signed in, please. Thank you. Yeah.
So I'm trying to get into that SharePoint, and
Uh-huh.
I can't edit.
You can't edit? Okay.
You all said that I can edit.
Okay. You're working also with Jen, right?
Yeah.
Let her know you can't edit.
Okay.
She'll give you edit.
Okay, cool. Yeah.
I'm gonna.
We went down there
I have to, Jen now, we're
Okay, yeah.
holding down the front office today.
Jen wears many hats. I guess you do too as well.
I am. Well, considering I do everything she asks to.
Yeah. I'm gonna scan this and then I'll send it to you.
Okay.
And then hopefully you can get these in soon
Okay.
too.
Yeah,
I don't think we got everyone. but
Yeah, as soon as I can get
try to
access.
figure it out.
you also have the
I'll start
list.
on that.
Awesome, thank you.
You also have the online list.
Yeah, so I forgot to ask who was online.
It should say in the Hangout. People to join.
The people. Oh, that's it. Let's see. Where am
You
I?
want to eat that last one and just give me the box?
Sure. I'll do it.
Thanks for taking one for the team.
Taking one for the team.
Now, eat the hot pepper one.
Okay. Where would I find the list of people that joined? All the names. Here. Ah, thank you. Okay. All right.
But that YouTube live. Or you can just ask.
Well, this is the YouTube live one. Let me shut it down now.